Today's topic is haloalkanes and haloarenes. Basically, haloalkanes and haloarenes are derivative of hydrocarbon. When one hydrogen of hydrocarbon is replaced by halogen, then haloalkanes are formed. Similarly, when one hydrogen of haloarene is replaced by halogen atom, haloarenes are formed. Basically, halogen containing compounds are very important in day-to-day life. Large number of halogen containing compounds are found in nature as well as they are synthesized in the lab. We know that in day-to-day life, carbon tetrachloride is used in fire extinguisher and chloroform is used as an anesthetic agent. In anesthesia, chloroform is used. Nowadays, the use of chloroform is not regular because chloroform is converted into a toxic material, that is phosgene, due to oxidation. That is why the use of chloroform for the anesthetic purpose nowadays is completely banned. The second compound is chlorophenicol, is used as an antibiotic against typhoid fever. It is very important compound, antibiotic, and very useful for typhoid fever. Thyroxine, iodine containing hormone, its deficiency causes gout disease. Similarly, chloroquine used in the treatment of malaria, and freon as a refrigeration and perfume industries, and Teflon, tetrafluoroethane, is used in non-stick cookware. In case of haloalkanes, when one hydrogen atom is replaced by halogen, mono-halo compounds are formed. If two halogen atom is replaced by two hydrogen atom is replaced by two halogen atom, dihaloalkanes are formed. Similarly, trihaloalkanes are formed and tetrahaloalkanes are formed. Monohaloalkanes like chloromethane, chloroethane, 1,2-dichloroethane. 1,2-dichloroethane is dihalogen derivative compound. Similarly, propane gives two type of compound, geminal compound as well as vicinal compound. Geminal compounds are those in which two halogen atom attach with same carbon atom, and vicinal compounds are those in which two halogen atoms attach with two consecutive carbon atoms. So geminal and vicinal compounds are again very important for the synthesis of large number of aldehydes and ketones. Carbon tetrachloride is tetrahalogen derivative. Trihalogen derivative like chloroform, bromoform and iodoform. Bromoform basically not stable, but chloroform and iodoforms are highly stable compounds. Chloroform and iodoform are used in haloform reaction for the identification of aldehydes and ketones. Basically, iodoform is widely used to detect methyl ketone in aldehydes and ketone. Any aldehydes and ketone containing methyl group is detected by iodoform test. Similarly, in case of haloarenes like chlorobenzene, fluorobenzene, iodobenzene and bromobenzene are derivative of benzene. Then classification of haloalkanes on the basis of number of halogen atoms. So haloalkanes divided on the basis of number of halogen atom: monohalo derivative containing one halogen atom, dihalo derivative containing two halogen atom, and trihalo derivative containing three halogen atom. So mono, di and tri halogen derivatives are possible with haloalkane as well as with haloarenes. Then classification of alkyl halide, on the basis of hybridization. sp3-CX bond means halogen attached carbon is sp3 hybridized. So sp3-CX bond is divided in three parts. Number one, alkyl halide or haloalkane. Primary alkyl halide, secondary alkyl halide and tertiary alkyl halide. The classification is based on number of alkyl group attached with sp3 hybridized carbon atom. Then the second part is allylic halide. Allylic halides are those in which halogen atom attached with sp3 hybridized carbon atom next to carbon-carbon double bond. Means halogen attached carbon is sp3 hybridized and next to sp3 hybridized carbon they must be contain carbon-carbon double bond. That carbon-carbon double bond may be in alkene system and as well as in cycloalkene system. Third part is benzylic halide. Benzylic halides are those in which halogen atom attached with sp3 hybridized carbon atom next to benzene ring. Benzene ring contain alternate single and double bond. Again benzylic halide divided in three parts. 1 degree benzylic halide, 2 degree benzylic halides and 3 degree benzylic halide. So classification of alkyl halide on the basis of hybridization. Number 1, sp3-CX bond. Number 1 is alkyl halide, number 2 is allyl halide and number 3 is benzyl halide. Then classification again based on hybridization, that is sp2-CX bond. sp2-CX bond means halogen attached with sp2 hybridized carbon atom and this one is divided in two parts, vinylic halide and arylic halide. Vinylic halides are those in which halogen atom attached with double bonded carbon atom.